Hello everyone and welcome to Routing with the Gang. In today's episode we have a luxury panel, so as always with yours truly Jesus Antonio, I'm joined by...
Hi, how's everyone doing? My name is Ángel Luz de Jesus López Ureta and I'm a soon-to-be software engineer, currently studying at CETI Colomos in Guadalajara, Jalisco, Mexico.
It's always a pleasure to be here. My name is Christopher Giovanni Levanos Torres, and as my fellow partner right here, I'm a software development student.
In today's episode we're gonna cover a couple of things. So first we're gonna see a brief introduction into what is a router. Then we are going to get into what are the routing decisions it takes when trying to send a package over. Then we're gonna talk a little bit about dynamic routing, what protocols are used, and then at the end we're gonna see a brief recap. So let's get right into it.
As a brief introduction, and to make sure that we're all on the same page, what we call routing is the process that the devices known as routers make in order to resend a package to its destiny, which can be on the router's own network or somewhere else where it would have to take more leaps before reaching its destination.
Following this topic, whenever a route receives a package, the first step to successfully resend it is to decapsulate it, eliminating the information from the second layer, which includes the MAC direction of the previous device so that it can access the network layer information, primarily the direction of the destination, so that it can look for the best route with the data on its routing table, whether it be statically or dynamically.
So at this point is when the router has to start making decisions on to where to send that package that just got sent to him. So the first case we're gonna see is when a package gets sent and its destination is to that same network. So let's say I don't know, PC3 sends over a package to the router, and this package is destined to be to PC4. In this case, well, the host network, the destination network that package needs to be sent, it's on the same network. It's literally connected to this router. So this is the easiest case for the router because it already knows which network he has to send it over, his own network. So then he only needs to encapsulate the package over again and then send it to the actual destination.
Another one of the possibilities that can happen during this process is when the destination host is located in a remote network, meaning one that is not the same as the routers. In which case, what is to be done is a leap into another router, which can lead the package to its network or close the distance to it.
Finally, the last possible situation is when the router doesn't know the network of the host and doesn't have a default gateway configured. This completely stops the package interchange by discarding the current package due to the lack of information necessary to complete the process.
So we just saw all of the possible decisions that a router may take to accomplish his main task, the package routing. However, one may have a deeper look into this process by looking at it from the perspective of fastest route selection.
Within the paradigm of dynamic routing, we can find the processes of the selection of the optimal route, which consist, basically, on the analysis of the different possible routes that the package can take to reach its target host, taking into consideration many different parameters, such as, but not limited to, the number of leaps needed to reach the target, load, bandwidth, reliability, etc. We can classify dynamic routing protocols based on many different parameters, but the main way to classify them is based on their functional pattern. Taking this into account, we can distinguish two types of dynamic routing protocols. The first one is called distance vector, which works by using the Bellman-Ford algorithm. This basically implies that the two main factors influencing the dynamic routing decisions are the distance between nodes and the number of nodes that the package has to go through in order to reach its destination. In this kind of protocols, each router has the information of every other router directly surrounding it, but not all of the network topology.
An example of this type of routing is the Routing Information Protocol, better known as RIP, that explains in a simple manner counts the number of leaps that the package needs to take on each different possible routes to its destination. Choosing the path with the least amount of leads, the routes are updated every 30 seconds. This protocol has become one of the most used routing protocols due to the fact that it's an open source, meaning that any router can use it, but also because it's one of the oldest protocols that use distance vector. Okay, as you can see in this image, the Routing Information Protocol, which decide for the route with the routing C, because have a minor amount of leaps in his way, and that's the RIP protocol.
So this brings us to another kind of dynamic routing protocols called link state. This one works by doing a sort of broadcast in the whole network so that every router sends a message stating its name and their location, so that every other router stores that message and shares it with their neighbors. At this point, everyone knows the state of the whole network, knows everyone, and knows their distances. So what's only remaining is to use math algorithms to calculate the shortest route when trying to send over a package. For example, a protocol called OSPF stands for Open Shortest Path First. Is one uses link state as opposed to RIP. Well, this one can recalculate a route in very short amount of time, thanks to this link state protocol. Also, there's another one called IS, intermediate system to intermediate system, and that also uses link state.
In addition to the Routing Information Protocol, we can also find the Enhanced Interior Gateway Routing Protocol, better known by its abbreviation EIGRP. This protocol operates very similarly to the RIP protocol, with the exception that it takes into account many more different parameters, such as bandwidth, time delay, load, and reliability. This is a protocol developed by the company Cisco, which implies that only the routers made by this company can use it.
Having said all of that, we conclude today's episode where we've seen routing decisions, dynamic routing, protocols, and a brief recap of package routing. Thanks a lot for watching. Don't forget to subscribe, hit that bell, and smash that like button.
Have a nice Thursday, everyone.